Okay, today we're doing Unit 1, Section 3, talking about absolute value functions. Okay, similar to everything we've been talking about this week, when we are translating functions, what happens when we add a C value to our function? Very good. It goes up, and if we subtract C, it will go down. You guys are so intelligent. And if we add a value in here, left is the correct answer, and if we subtract it, it will go to the right. Except for when it's in parentheses, remember you would it ends up becoming the opposite. When you would like take it out of the parentheses, you'd end up moving things around. Okay. What happens when we have a negative in front like that? Where does it reflect? Very good, on the x-axis. And when we have a negative inside the parentheses like this, it ends up reflecting across the y-axis. Very good. One thing that's nice is that all the different functions and stuff that we've been talking about have similarities, right? So these things are the same for everything, therefore hopefully we will remember them. Okay. Also, when you have an A value in front, what's going to happen, do you think, with the linear absolute value if you have a value between -1 and 1? If you have a fraction, it will become wide or narrow? Wide. Okay? And if the value is greater than 1, whether it's positive or negative, it will become narrow. Okay. And just for the fun of it, we're just going to look at these really quick. So, let's see if this can show up here. All right. So, if I have the function, I might have to make this. There we go. So, again, if I have f of x, and we just did equals, and notice down here they have the absolute value lines, and we're just going to do the absolute value of x, you can see that, right? Now, is there any way of getting this to go down to the bottom? What could we do in order to make it flip down? You think a negative x on the inside of the absolute values?
No.
No, where would the negative need to be? Which is representing the A value, right? So let's see. So if I do a negative in front, see how it flips down there to the bottom? Okay, now let's take that off. So let's go ahead and look like what happens when I put a fraction of 1/2. See how it becomes wide? Or if I have the value of, let's just say 2, see how it becomes narrower. All right? And then inside, if I do x minus 3, what's going to happen? It's going to go which direction? Good, right 3. Do you see it? Where if I did plus 3, it goes left.
Yeah.
And what happens if I add 2 on the outside?
It's going to go up.
Or subtract 2, I mean. Oh, where'd it go?
You pressed equals.
Oh my goodness. Oh my goodness. Okay. Let's go backwards one more time. There we go. We're going to take this away for a second. Oh, I see, because I made it way bigger. Okay, you guys get the idea, right? We're all good? Okay, I'm just going to take this away for a minute. It was that too. Okay, so these are very similar with finding our vertexes. The absolute value is your x value, okay? And so you can think of it as like being in parentheses. So when you were finding your vertex for these, so again, very similar to our parabolas, our quadratic functions, we're going to do our v and our a value. What is my v value on this one? 2, 0. So with the x, when we take this out of the absolute value, it's going to be a positive 2. And then there's nothing being added at the end, so that is a 0. Okay? Next, when we graph it, let's go ahead. What is the a value on this one? Good, 1 over 1. And then I'd like you to go ahead and, actually we hadn't even talked about it. Okay, so write 2 up 0. Correct? And then we'd go up 1 and right 1 and up 1 and left 1. And then remember that these are not curves. These are actual straight lines. Okay, questions? All right. Okay, so on the one to the right, what is this vertex going to be? Good job. And what is my a value on this one? 1 over 1. So 0 up 2, we go up 1, right 1, and up 1, left 1, and make our graph. Okay, now we're going to go ahead and talk about domain and range now. So going back to that first example, what do you think my domain is? So domain's dealing with the x values. So remember, this is your x is what's going right and left, and your y is what's going up and down. X is dealing with your domain, where y is dealing with your range. Okay? So if we look here, going right and left with all my x values, what is going to be my domain? Very good. Negative infinity to positive infinity is correct. Or you could also write all reals if you want to. Now the range is going to be a little different. Okay, because is it going to hit all y values for this graph? No. Okay, so what is my smallest y value? 0. And will I use a parenthesis or a bracket? Bracket. And why a bracket? True, but specifically is that it equals that value. So remember, if it has an open circle, and you'll see that later on when you're looking at some graphs, then it would do the parenthesis because it wouldn't equal that value. It would be anything like above it or below it. So that's going to be a bracket, which is 0, and then goes to what? Positive infinity. And infinity always has a parenthesis because there isn't an ending point for infinity, right? Okay, so now you do domain and range on the second one that we did. Okay, so for the domain, what's it going to be? All reals, or negative infinity to positive infinity. And for the range, it will be 2 in a bracket all the way to positive infinity. Good. All right, this one I want you to try it all on your own. Okay, that's good. All right, looks like most of you have it. So on this, my vertex is at -1, -3. My A value always comes from the number in front. Okay, in this case, there's no number in front, so that's 1/1. So I go left 1, down 1, 2, 3. And then from there, I'm going to go up 1 and right 1 and up 1 and left 1 and draw my lines. And domain is what? Very good. And range would be? Good. And so if you look on the y-axis, the smallest y value is down here at -3. Okay, and it does equal -3, and it goes all the way to positive infinity. Questions? Yes?
So whenever you're doing the range, the smallest y value is what you put in the bracket, right?
Well, it depends, because if it was going down, my smallest y value, that's all put together, would be -infinity, and you can't put -infinity in a bracket.
Okay.
Okay. All right, any other questions? What will I do on this next one? Because it looks a little different. Well, so if you look, they just kind of wrote it in a different order. This -1/2 with the absolute value, this part needs to stay together because this is your A value, and this is saying -1/2 times this. Okay? But the 3 they put in front instead of at the end. Okay? Which doesn't really matter, but it just doesn't look like the way that we normally see things. A lot of people want to do like subtract 3, but we're not subtracting 3 because it's on the same side. We just want to move this 3 to be at the end. And so if we rewrite this, it's y equals -1/2 absolute value of x minus 2 plus 3. Do you guys get that? So we're just changing the location of it, but it's still on the same side. So that's why you're not going to like subtract or do anything. You're just moving it around to look the way that we like it to look. Okay? Can you guys try graphing this one and doing the domain and range now? Great.
So when you're trying to figure out like the A value, so it would be the -2 because of
So like, whenever that these we can think of these, so even though it's not exact, actually I'm not also adding into this. It's the only one that doesn't is on the quadratic fraction one that you're gonna go down 1 and right 1 2. So it's always right.
okay, so that's why this is my A value. Okay. Thank you.
You're welcome. Okay, so what is my vertex on this? Positive 2, 3, right? Because whatever's in here, opposite. Okay, so we go right 2, up 1, 2, 3. And then what is my A value on this? So that means I'm going to go down 1 and right 2, or down 1 and left 2. And then we can draw our lines. Okay, and so what will my domain be? Good, all reals or -infinity to positive infinity. And then my range? Good, parenthesis, -infinity, because my smallest value is -infinity, right? Because it's going down. And then my largest value is 3, and that would have a bracket. Any questions here? All right. Okay, do you think you guys could write this absolute value function on your own? Give it a shot. Let's see. Okay, check in your group, see if you guys agree. Okay, so what is the vertex on this? -1, 3. And our A value is what? -1/1, which reduces to be -1. Okay, when we write this equation, you can start with f of x or y. Since it says function, I'm going to go ahead and write f of x. If it says equation, then I might just write y. But either way, you're fine. And then what will I write next? Good. Then what? Very good. Absolute value. X. Good. +1. And then +3. And there's your answer.
So it's like the opposite value bars, you can get negatives out of them. So pretty much just like parentheses unless there's another part of x.
It is just like parentheses because the value that comes out in terms of like your vertex will be the opposite. But when you put values in, whatever comes out of them becomes a positive. So inside, it's a little confusing. But think of them as parentheses. Yes?
For that, can you just write the negative instead of the same
Yes.
thing as -1?
Yes.
So I have y equals -1.
Exactly. So you brought up a good point in that do you have to have that 1 in front? No. So instead of having it written this way, the way we would actually probably see it more often would just be negative absolute value of x plus 1 plus 3. So either way is good, but this is actually probably better, the part in red. All right, any other questions there? Okay, try doing the next one. Okay, so we're trying this one, unless you're already done. Hear me. All right, so what do we get for our vertex here? Very good. 1, -3. It is 1, -4. Good job. Okay, and what is my A value?
3/1.
Good. And 3/1 reduces to be just 3. Okay, so when we write this equation, f of x equals what will go in front?
3.
Good. Absolute value.
X minus 1.
Perfect. And then -4. Okay, now we're going to move on to translating graphs. So we have f of x, and then we're going to translate it to be f of, or negative f of x. So when we write this first equation, what is my vertex here?
3, 2.
Good. And my A value is 1, so we have 1/1. So I go right 1, 2, 3, up 1, 2. Go up 1, right 1, up 1, left 1. Draw our line. Okay, what's going to happen when we put a negative in front? Good. So how will we fix that on here? How do we do that?
Count how many, like,
Good. Count down. So this point is 2 from the x-axis, so I need to go 2 from the x-axis. If you notice, this one is 1, 2, 3, so 1, 2, 3. And if you notice, when you count away, it ends up making it go the opposite direction. Correct? So therefore, my answer as well, because they want us to describe the transformation, we would just say that it reflects over the x-axis. So you can just do R with the x-axis. Okay, so let's go to the other side here. H of x. So starting here with my first equation, what is my vertex? Good. -1, -4. And my A value is? Good. So we go left 1, down 1, 2, 3, 4. From there I go down to right 1, down to left 1. And then what's going to happen when I add 3?
It's gonna move to the left 3 spaces.
Very good. It's going to end up moving left 3 spaces. So left 1, 2, 3. And then each of these would go left 1, 2, 3. 1, 2, 3. And so my translating would be, hi there.
Should we come back later?
Yeah, can you guys give me about 10 minutes and then I can take them down, okay? So it will be -3, 0 in terms of translating, because we're going left 3 but not up and down at all. So again, think of these as x and y. And so we move -3 on the x and nothing on the y. Okay, questions for either of these?
so like that little thing right there needs to be translated into that.
And if you write left 3, that's fine, but you'll end up seeing it kind of written like this. Okay. So you could write both, like if it went left and right, up and down, like both of those values in there. Okay. Next one's graph the functions below and describe the transformation from f of x to g of x. So I'd like you to try this one on your own. So you're going to graph both of them, see what happens. I'm going to be coming around and checking. The first 2 to get it right are getting a candy. So raise your hand when you got it.
The first one?
What?
The first one?
The first 2 people to get it right. You already got it? Okay. He didn't know. Beautiful. Shows what you do that. Don't look at cheat. Did you have papers? I know it. You got it? I have one more. So what happened? So how do you write what happened? Now, did it move at all on x? Did it go right or left as well? This is all like 0.
What?
Did somebody raise their hand?
I say guy, but we already gave that.
I already gave out all the candidates, but you got it right. Good. Okay, so here we go. Most of you got this right. Some of you are still working on it, which is okay. I'm just going to get started. So for this first one, this vertex is at -3, 0, and my A value is -1 over -1. So I go left 1, 2, 3, up 0, and then down 1, right 1, down 1, left 1. There is my absolute value graph. This vertex is at -3, 5. So left 3, but then up 1, 2, 3, 4, 5. Hope I'm counting right there. And my A is -1 over 1. So going down and down. I normally will mark them like this is number 1, so I remember which one I started with to know which one I'm going to. Because if I started here, I'd be going down 5, but since I'm starting here, I'm actually going up 5. Do you guys get what I'm saying? So just pay attention to which one is your first graph. So translating on this one, we didn't move right or left at all. So 0 on the X, and then from here to here, it went up 5 on the Y. And so it's the same thing as writing up 5, but this is actually a little bit nicer. Okay. Did anybody already figure out the second one? Okay, what's my answer?
To the translation 5, 5.
Good. Anybody else? Okay, so the translation is 5, 5. So let's go ahead and go through this one together. So my vertex here is at -2, -4. My A value is 1 over 2. So left 2, down 1, 2, 3, 4. And then it's going to be +1, right 2, +1, left 2. And I feel like maybe I'm going too fast, so I'm going to wait a second. Okay, so then the second one, vertex is what? 3, 1. My A value on this one is 1/2 as well. So I go right 3, 1, 2, 3, up 1. And then we go up 1, right 2, and up 1, left 2. Did you, oh, okay. She left. Did you want to do CSF or something, or? Oh no, it's for class. You have me next period. I got it. Okay. It's okay. All right. So what happened here? What is the translation? Good. And so always do your right and left first, your X values. So if you count going to the right, it's 5. And then from there, it goes up 5. Okay, so the end. It says, write the graph of an equation of an absolute value function that passes through the lattice points, the heart, and the flower, but avoids the wall, which is the line segment. So on these, I normally will label them. So heart is at 0, 0, and my flower is at 1, 2, 3, -3, down 3. Okay? So it doesn't say we have to make the graphs go up or down or anything like that, but we have to use an absolute value function. So what do you think would be a good vertex for this one? You want to do the flower? Okay, and so if the flower's our vertex and we're avoiding this, which way is my absolute value function going to go? Up. Okay, so we're thinking we're going to go like this and like this. Does everybody agree with that?
Yeah.
Okay, so the flower is my vertex. When I'm writing this, I'm going to write this as y equals. We're going to need some kind of a value in front. I'm going to put an a there for right now, and then we're going to do absolute value of x what?
Plus 3.
And then what goes at the end? Plus 3 again.
Wait,
No, it's minus 3. It's going down on the y-axis.
You are right, it is minus 3. Thank you. Candy. Okay. All right. So, what do you think if we go from here and if you're going up one, right one, up one, right one, up one, right one, and this will work for absolute values because they are lines. So your a value will be perfect. It looks like a could just be 1. Or if you count it up, 1, 2, 3 over 1, 2, 3. 3 over 3 is 1. So my a value is 1. Now, to make sure that you've done it correctly, you would want to plug in a point. So let's plug in our 0, 0 to make sure it checks out. And so we'd go 0 equals 1 absolute value of 0 plus 3 and then minus 3. Okay, what is 0 plus 3? Okay, so with absolute values, you always figure out the answer to the inside first. When you take 3 out of the absolute values, it becomes a positive 3. And so then we have 3 times 1, which is 3, and 3 minus 3 equals,
0.
so it does check out. So that would be my equation, y equals, and then we just have absolute value of x plus 3, because I don't need to write the 1, minus 3. So now it says, write a different equation. So you have 1, that's great. Can you write another one? Can we? Okay, which would be my vertex on this one?
A heart.
The heart. Okay, because I can make it going through like this, correct? Something like that?
Yeah.
Okay, so go ahead and write what you think your equation is going to be. Okay, so we have y equals, what do you think my a value will be? Good, -1 or negative. I'm going to go ahead and write -1 just so we can see what's happening. And then what's going to be inside my absolute value bars? Just x. Because if you have 0 and then adding at the end is 0, because we're going to say on this one my vertex is at 0, 0, because that's where the heart is. Okay, always double check by plugging in the other point. So I'm going to plug in my -3, -3. So -3 equals -1 absolute value of -3. Well, what's the absolute value of -3? Positive 3. What is -3 times a positive 3? And so it checks out. -3 does equal -3, so we know that we did come up with an equation that does work. So when we get to our performance task, you're going to be doing the same thing, where you have to check your work. That's what you're going to be doing on that other form, telling me that this point actually does fit into that equation.